Assalamu alaikum. This is 12th chemistry, and our today's lecture is about aldol condensation. This is a well-known reaction which is shown exhibited by these carbonyl compounds, that's aldehydes and ketones. And we have got a few more reactions. We have got Cannizzaro reaction, we have got Perkin reaction. But as our today's this lecture is about this aldol condensation. Now, as far as this aldol condensation is concerned, in this reaction we see aldehydes and ketones which have got alpha hydrogen. That means the hydrogen atoms which are attached to the adjacent carbon, which are adjacent to the carbon atom which is adjacent to the carbonyl group. They undergo self condensation in presence of in a weakly alkaline medium, or in a dilute this alkali, to form beta hydroxyaldehydes or beta hydroxyketones. Now this reaction is called as aldol condensation because since aldols are formed, aldols means where we have got two functional groups. We have got an aldehyde group and we have got a hydroxyl group. Now, as far as this reaction is concerned, I have told you that this reaction is shown only by those carbonyl compounds, or those aldehydes and ketones which have got this alpha hydrogens attached to the carbon atom which is attached adjacent to this carbonyl carbon. Now that means this reaction is not shown by formaldehyde, where we don't have got any alpha hydrogen. Similarly, this benzaldehyde, which too has got no these alpha hydrogen. So these two molecules, that is formaldehyde and benzaldehyde, they do not undergo self this aldol condensation. Now, as far as this reaction is concerned, you can see here I have shown here two molecules of this acetaldehyde ethanol molecules. They condense together in a weakly this alkaline medium. This is a weak base, and they give rise to the formation of this in this aldol, or we can call it as beta hydroxy butanol. You can see 1 2 3 4, that means, or we can call it as 3 hydroxy butanol. now now the mechanism of the reaction involves the first step. Since the reaction is carried out in a weakly alkaline medium, the first step that involves the generation of this nucleophile. Now you can see in the first step, this base, it picks up a proton. This is an acidic proton from this aldehyde molecule. This is alpha hydrogen, and it picks it up and it gives rise to the formation of this nucleophile. And you can see here this negative charge on this carbon atom. It is in conjugation with the oxygen of this carbonyl group. Now you can see how this negative charge gets delocalized over this oxygen atom. Now the second step, in the second step of this reaction, it involves the attack of this nucleophile on the carbon of the other this carbonyl group, carbonyl group of the aldehyde molecule. You can see here, this is the second step where we see this nucleophile attacking this carbon atom. Now it gives rise to the formation of this anion intermediate. Now this anion intermediate is formed. It then this anion, in where we have got a negative charge lies on this oxygen atom, and it then picks up a proton from the solvent to give the final product of the reaction, that is this beta hydroxy butanol. Now this is I have told you that these aldehydes which don't have got these alpha hydrogens, they do not undergo this self condensation. Then we have got a cross aldol condensation. Now this condensation, as it involves we have got two different these carbonyl compounds are involved in this cross aldol condensation. Now you can see here, I have shown here, this is aldehyde, acetaldehyde, and this is acetone. Now again the reaction proceeds through the similar mechanism as which I have shown above. Now this base, it picks up this proton from this acetone molecule. You can see here, this is an acidic proton, and it gives rise to the formation of this nucleophile. And this nucleophile, in the next step, attacks this carbon of the aldehyde this molecule, and to give rise to the formation of this anion intermediate, which then again which then picks up a proton from the solvent to give rise to the formation of this final product. You can see here acetone. It reacts with acetaldehyde, and it gives rise to the formation of this is beta hydroxy pentan 2-one. That the reaction takes place between acetone and aldehyde, so that is why we call it as cross aldol condensation. Now we can also call it as this 1 2 3 4. It is 4 hydroxy pentan 2-one or beta hydroxy pentan 2-one. Now in this cross aldol condensation, this is useful only when uh, one of the carbonyl compound doesn't have got alpha hydrogen and and do not undergo this self condensation. That is in case of this formaldehyde, and in case of this benzaldehyde, because there we don't have got any these alpha hydrogens. You can see here, this is benzaldehyde, we don't have got any alpha hydrogen, and benzaldehyde, it reacts with this acetaldehyde, which has got these 3 alpha hydrogens. Now this benzaldehyde, it reacts with acetaldehyde in presence of this weak base, and it gives rise to the formation of, you can see here, this is you can see it is a 3 phenyl. In this case, you can say it is 1 2 3. This is 3 phenyl 3 hydroxy, and this is 1 2 3 propanol. Now you can see in the same, this is when the nucleophile attacks this carbonyl of carbonyl carbon of this benzaldehyde, and it gives rise to this the formation of this product. Now in the next step, when this is heated, it is heated, it loses then a molecule of water, you can see here, and it gives rise to the formation of cinnamaldehyde, or we can call it as 3 phenyl this propan it is 3 phenyl prop 2 enol. That means we have got at carbon number 2 we have got a double bond, and to the carbon number 3 there is attached the phenyl ring, so we call it as 3 phenyl prop 2 enol. So this is the reaction between this benzaldehyde and this acetaldehyde. Now in benzaldehyde, as I have told you, we don't have got any alpha hydrogen, so this is cross aldol condensation. Then we have got this another reaction between the benzaldehyde when it reacts with this acetone molecule. Now as I have told you that this reaction involves the condensation of this is aromatic aldehyde and a ketone in presence of dilute alkali, and it gives rise to the formation of this beta. It gives rise to the form alpha beta unsaturated compound. You can see here, this is benzaldehyde, it reacts with acetone, and it gives rise to the formation of this is 1 2 3 4 5 1 2 3 4. This is 4 phenyl 4 hydroxy butan 2-one, and this then loses the one molecule of this water. You can see in the next step, on warming it, it loses a molecule of water, it gives rise to the formation of this is benzyl. This is benzyl 1 2 3 4. This is benzyl. You can see here, this is a phenyl ring is attached to this 1 2 3 fourth carbon atom, so we call it as 4 phenyl but 3 in 2-one. So this is cross aldol condensation, where we see the condensation takes place between two different aldehyde molecules, or between an acetone and an aldehyde. Aldehyde may be aromatic aldehyde, that is benzaldehyde, or it may be an aliphatic aldehyde. So this is about this aldol condensation, and in our next lecture we will discuss this Perkin reaction. This is for today. Thank you.